We've already done this division using powers of 10 in the classroom, but I'm going to go over this again and make a screencast of it so that I can then add it to Haiku as a tutorial. We're going to go back and continue to review dividing by powers of 10 as an alternate method of division, and this will give you something to use as a reference. So in case you forget what the steps are or exactly how you would use it, this would be a good reminder. So here we go. I'm going to take a look at the essential question that we have. How can I use various methods of finding equal groups of numbers, which is basically what you do when you divide. You want to know how many equal groups of a number I can take out of a larger number. And the question I'm asking here is, how can I use powers of 10 when dividing? So instead of the standard algorithm where you look at how many times would one number go into another, I'm going to look at powers of 10 of the number that you're dividing by to be able to pull out equal groups of that. So both division problems, as you've noticed, are the same here. 761 divided by 3, 761 divided by 3. The quotient that I'm going to get, the two different ways that I'm doing this, is going to be exactly the same. So the method that I'm using for the first one is not going to be the exact same thing that I'm doing for the second, but the answer is still going to be the same. So let's start with the one on the left. 761 divided by 3. Well, I could do the standard, 3 goes into 7, how many times, and divide, multiply back, subtract, bring down, or I can look at powers of 10. Well, powers of 10 would be 3 times 10, 3 times 100, 3 times 1,000, and I want to use a power of 10 that's going to get me as close to 761 without going over. So what power of 10 could I use? Well, 3 times 100 is going to be 300. That will definitely fit into 761. So let's see what we have. Oops, that wasn't supposed to happen. Cover these back up again. Suppose I could always use this as an outtake, but we're going to keep it just like this. Okay, I had my actions turned off. When I turned it back on, it removed too many. So here we go. 3 times 100 is 300. The number that I'm putting on the outside of the division model here is the number of the power of 10 that I'm going to multiply 3 by. So I said 3 times 100 is 300. I can go ahead and subtract out 300 and I get 461. I want to use another power of 10. Again, 3 times 10, 30. I don't want to keep subtracting out groups of 30. That's going to take way too long. But I can subtract out another 300, which is going to be multiplying 3 by 100 again. And sure enough, there it is. Now, when I subtract this, I'm going to have 161. I can no longer take out a 3 times 100 because there's not enough. 161 is much less than 300. I can still use a power of 10. 3 times 50 is still a power of 10. It ends in a 0. It's a power of 10. 3 times 5 is 15. 3 times 50 is 150. And when I subtract this, I have 11. Well, now I need to think about what number or what multiple of 3 could I use that would not go over 11. Well, that would be 3. 3 times 3 is 9. Subtract, I've got a remainder of 2. 2 is smaller than 3, so I'm done dividing. Then I'm going to add up the numbers that I have here on the outside. And there's 100, 200, 250, 253, and a remainder of 2. And remember when we talked about how to write the remainders in class? and we had talked about putting R, the letter R for remainder, and then the number, mathematically has no significance. But if I have 253 and 2/3, mathematically that does have significance. So you will be writing your remainders as a fraction. Your denominator in your fraction will be the divisor in your division problem. The numerator in your fraction will be the remainder in your division problem. So 2/3 or 2/3. Now, I said this other model is going to also use powers of 10, but it's going to look a little different. So what could that possibly look like? Well, in class, some students looked at, well, I've got 100 and another 100. Why can't I just combine them and do a multiple of 3 times 200? Why not indeed? 3 times 2 is 6. Write 2 zeros after for multiplying by 200, and you've got 600. It took us 2 steps here to subtract out 600. We did it in 1 step here by multiplying 3 times 200. So now, the next is going to be 161, subtract 150, exactly the same thing we had here. We're going to have a remainder of 11, and then we're going to multiply 3 times 3 for 9, and the exact same thing. Okay, so now, let's take a look at another example. Can I use this when I'm dividing by 2 digits? Well, what do you think? Notice I got the quotients covered up this time. Using exactly the same process, using powers of 10. So 16 times what is going to give me a number close to 432. Remember, I still want to use powers of 10. So, well, if I multiply 16 times 10, that would give me 160. Can I get even closer? And yes, if I multiply 16 times 2, that will give me 320. I'm going to subtract, I've got 112 left over. And 16 times 7 actually works out to be 112. So now I've got 20 plus 7, quotient 27. So what do you think the difference is going to be on this one? I multiplied by 20 here. What do you think this one is going to be? I divided this in 2 steps. I'm thinking this is probably going to take me 3 steps. And sure enough, 16 times 10, 160. Subtract 272. Take out another group of 160. You've got 112, same thing you had here. And 7, multiply by 16 by 7, and you get 112. Your answer is 27. So now we're going to add 10 plus 10 is 20 plus 7 is 27. Now, a word problem. A bus holds 63 students. If 2,442 students are going on a field trip, how many buses are needed? And I'm going to add a little note here to make sure that you think about, is your answer reasonable? Well, I still want to look at powers of 10. So, what do you think? What could you use? I've got 2,442. I could do 63 times 10. That would give me 630. Could I get a little bit larger? How about 63 times 30? That would give you 1,890. Subtract 552, and then what would you use? 63 times 8 gives you 504. You've got a remainder of 48. Can you take anything else out? Well, if you've got 48 left over, there's nothing else here that you can divide by. This is not a decimal, and 63 is larger than 48. You're done. Quotient is 30 plus 8, or 38, and 48 63rds, or 48 over 63. Okay? Is your answer reasonable? Well, let's think about this. How many buses are needed? Well, we know that we're going to need 38 buses, but we've got 48 people left over. Can you get 48 63rds of a bus? So would we need 38 buses, or would we need 39 buses, or are we going to leave 48 people behind? Well, no, we're not going to leave 48 people behind if you're going on a field trip. So you would need 39 buses. Leaving 38 and 48 63rds would not be a reasonable answer, because you cannot have just a portion of a bus. So your answer to this would be 39 buses. Okay? This was the next part that we had in the classroom, that you would be working with your partner to complete division problems. You may have another assignment, or you may have a homework assignment where you need to be using this, so that would be a perfect time to go back and replay this tutorial so that you can see all of the steps that you would be using. I hope this has been useful for you, and that you are able to go back and review this. Maybe share it with your parents and teach your parents how to use this model. Okay? Good job.